Live streaming is on. Live streaming is on.
So we'll start in 2 minutes.
This morning, I guess. I wouldn't be surprised.
Yeah. Good morning, Eric. So we will start the opening session now. I don't know if everything is okay online, just to make a testing. So you can see the slide, you can see the Senat Sal, the YouTube stream. Zeb is also online. Everything works. Thank you so much. You can hear me well as well on site, online. If there is any issue, please write in the chat as yesterday, and we try to solve everything. So, good morning, on-site and online participants for this day 2 of the MIWI 2021 conference. We aim to discuss about elucidating and engineering microbiomes today. So, what did we do so far on day 1? So, we addressed microorganisms in the general context of water resources in different sessions across microbial ecology on the water sector, on microbial resource management for water and waste engineering, and on microbial ecology and the water sectors with different keynotes, oral presentations, poster contributions, and roundtables. I hope that the interaction that you could have online, on site, was nice for you. It's clear in a hybrid mode. Murphy's law is exponential, and we just have to react to facilitate the streaming. So today we will focus on elucidating and engineering microbiomes in 3 sessions, again, on functional ecology and metabolic insights, on theoretical ecology and engineering theory, and on how can we integrate systems microbiology into this engineering context. We will have different keynote lectures again. So Takashi Narihiro from Japan will speak about simplifying and understanding the wastewater treatment microbiome. Leonardo Eraiman from Argentina will speak about the community assembly in activated sludge. And Morten Dueholm from Aalborg in Denmark will speak about the database MIDAS4, this world database about microorganisms of activated sludge and anaerobic digesters. And we'll have also the opportunity to listen to Leslie Robertson, an emeritus researcher from the TU Delft, who is curating the Delft School of Microbiology Museum, and she will speak about Delft historical microbiology. Is it of use for us 21st century biotechnologists? So it will be in the early afternoon as a special keynote presentation. And Leslie notably reproduced the experiment of Van Leeuwenhoek with this small microscope that I showed yesterday. I would like to know if Niti is online. Niti is our young water professional representative. Niti, are you online?
Yes, I'm here, David. Good morning.
Yes. Good morning, Niti. Can you switch on your video? Yes, great. We'll see if the streaming will work. And it's the aim now to ask you on the participants on site, online, also Nina and Jay, who will moderate with me today. What are the take-home messages from yesterday? So let's take 5 minutes to fill in maybe 3 messages. And Niti, do you have already one main message from yesterday that I can fill in and that participants can fill in at home?
Yes, certainly. We've seen a rich discussion on how new methods have come up with addressing microbial ecology basics and application. And in this regard, we saw the discussion on next generation techniques, which can help complex problems or process failures. And the issue of generating a lot of data can actually over intensify monitoring of biological systems. So it led to thinking of, do we need to know more, or do we need to know specific aspects of microbial ecology in terms of wastewater
Indeed, the message is a bit how far to go. Could we go always more with resolution, or should we be more targeted in our analysis as well? This is a great message. Nina and Jay, do you have a message to convey us from what you have seen yesterday? You can unmute your microphone as well.
I think sampling is still a very important part of our study to get what we want to answer.
Indeed, all the measurement that we will do relate to the sampling. So we discussed with Francesc, for instance, in the drinking water systems, where to sample, how frequent to sample. We discussed in the early session with Benjamin about these autonomous systems as well that can give somehow data on real time, but to which extent, or how far should we sample, how frequently should we sample? This depends on the experimental design as well. Nina, do you have also a message, an additional message from yesterday?
Yes. I think particularly from session number 3 yesterday, we saw that although a lot has already been done for the drinking water systems in terms of knowing about the microbiology, there's still a lot unknown and a lot of complexity that needs to be understood.
Indeed. And we think that wastewater is complex, is a complex community, but it seems that drinking water systems are even more complex to address. I'm just typing at the same time here. Water microbiology. Still. Address. Yeah. And I remember once a presentation of Lut Raskin at EAVAG, where she was saying it was 5 years ago that really the drinking water microbial ecology and microbiology is a niche. if you compare the number of publications on wastewater microbial ecology and on drinking water microbial ecology, and there is really a difference in the number of publications, and we need to implement much more methods, or how to implement these methods in the drinking water complexity, and this relates notably to the biomass concentrations that we have, or the low biomass concentration that are in drinking water. And we address as well about the functions, so functionalities of microorganisms. So what are the functionalities that we are interested in? So if we think about activity/population dynamics, so the former name of MIWI, it's about linking to the traditional BNR processes, COD removal, nitrogen removal, phosphorus removal, maybe sulfur removal, or other types of components to remove, and to look at what are the populations that are active in that, and how they are selected in these systems. For drinking water microbial ecology, what are the functionalities that we want to address? Are these some metabolizing functionalities, like removing ammonium, or transforming ammonium, or removing nitrate? Or do you want to remove micropollutants? Or do you want to avoid to have a biofilm? So there was a nice take-home yesterday, I think it was from Xiaoxia, about please don't grow. I think I will make a song about that. It's really nice. So we have 3 nice messages here from yesterday, and I invite you at your home institution maybe to take 1-2 minutes to reflect in silence and to think about what are your take-home messages versus your expectations that you have for this conference. So let's move forward with the day today, and I would like to invite our sponsor, so Shaya Algoe from SWECO, to present about the activity of SWECO and how it links also to the thematics of our conference. So put your slide. Mentimeter, is it? Sorry, I conveyed you too early.
Revealing all the surprises. Great.
Very good. And you need a pointer?
Good morning, everyone online and on site. My name is Shaya Algu, and I have with me my colleague Verike Molema. We work for SWECO, to be specific, SWECO Netherlands, and today I would like to share a few notes on our daily practices, especially how we incorporate microbial processes in our daily work. And as you already can see on the screen, SWECO stands for Transforming Society Together. So let's start with an activity together. So Verike?
I will start the Mentimeter. So if you can all go with your phone or on a website or on your laptop to menti.com, then you can fill in a code 84483337, and then you will get a question.
No.
So if it's working, I think. Yes, it's working. I see one answer already. So the question is, according to you, what type of company is SWECO? And we are asking this question because we just want to know, how much you already know of our company where we work for.
So nice to see that the system is working. That's good. And there are answers coming. So keep the interaction going. We'll wait for a few seconds to see the results.
Yes. Hoeveel mensen zitten er ongeveer? So just 1 more minute to fill in the question.
And we should normally have 220 answers, huh?
So I think we have pretty much a lot of answers. There are still some coming in, but to spare some time, I'm going to move on. And it's nice to see that many of you already said that we are a consultancy. That's good. That's a good sign. So let's go to the presentation now. Next. Yeah, so indeed we are a consultancy, and to be more specific, architecture and engineering consultancy. We have approximately 17,500 employees and working from 14 different countries in Europe. And our employees, they have very different background. I myself have a background in environmental technology and life science and technology. Verika has a background in biogeochemistry. We have architects, we have process engineers, we have toxicologists, we have people working on building roads, building houses. So it's very, very, very diverse. And our purpose is designing solution specifically in terms of urbanization, and we incorporate digitalization and with a broader aspect to make our society sustainable. That may sound very robust, I would say, but we perform this on different levels. So you can think on an ecosystem level, on a micro scale, on a macro scale, but also on a scale of building houses, the climate adaptation. So it's very broad. Therefore, Sweco is divided in three main segments, I would say. So you have the first segment, which is the building and urban districts. And that's a part about the city, the architecture, the environmental part, environmental risk assessments, which are performed within this division. And on the other hand, we also work on renewable energy, water treatment, wastewater treatment, and also infrastructure, so helping the trains to build new railways and so on. I must say this is very general. So all these different segments, they work together very closely, and I've barely had a single project where you just work with your own departments. It's pretty much a lot of collaboration. So later on, I'm going to explain to you a few projects of Sweco, and there you will see that probably it fits in the water and energy industry, but it is a project run by the buildings and urban districts. So this is just for a little bit structure, I would say. And as already mentioned, I'm going to give an example from the first department. And what Sweco is a consultancy in the middle of different stakeholders, different type of stakeholders. We have clients from the industrial companies, we have clients from the municipality, we work together with research institutes, with universities. So it is a very broad range, with also actually demands from us to stay focused and focus from a practical point of view. So what are challenges that nowadays are present in the practice, and how can we tackle them, and especially with an integral strategy. That's also what I believe the power of Sweco, because we have all the expertise in house. We can combine all of them to go to our clients and give an integral solution. So that's very, very important for Sweco, the practical focus. And that's also the field where we are constantly improving and trying to be one step ahead. And if I go a little bit further, I would like to explain one of the practical challenges. With due respect to our clients, we have kept all the location names and any traceable information, let's say, not displayed. Just that's a promise we have to our clients. We have to keep that. But one of the actions which is done between the department I work for, specifically the environmental science department, is remediation. remediation of polluted ground and groundwater. And this is done in a very diverse context. For example, sometimes you have a new the desire of clients have the desire to build new houses. So you have to look at the species which are living there, the quality of the soil. You also have to look at the environmental risk assessment. So it can be for different purposes. On the other hand, you can also have spills, for example, where some cleaning is important to prevent any human health effects. But for this specific site, it was a site situated in the Netherlands. Previously, it had been in industrial activities where they were producing different types of chemicals, and the soil and groundwater was polluted with chlorinated hydrocarbons. In the graph on the left, it's displayed as per entry. So you can see it in the, I must say it correctly, I think it's the gray one. Yeah, so the gray chart. Can you point? The gray chart and the yellowish ones. So those two are the main ones. Maybe I can use the pointer to make it a bit clearer. Yes. So yeah, this gray chart, that's the one displaying the contaminant, the product, let's say, main product, and tree. So that's also one of the main contaminants of concern on the site. So this is already 20 years ago, I must say. And so what did they do at that time? They used one of the conventional remediation methods, which was excavation. So the soil itself was the source of the pollution. So they excavated a lot of polluted soil from the site, and we were left with residual groundwater pollution of chlorinated hydrocarbons, which means that the owner of the site, which in our case was the municipality, they had to on yearly basis perform monitoring of the groundwater quality to ensure that there is no spreading risk and there is no risk for human health, which means that this is costly, of course. I mean, for one round, you can think of €1,000 for solely getting an idea about what is the quality of the groundwater at the site. At some point, we were discussing about novel techniques and all of the innovation which is happening around this area. And we thought, maybe we can think about how we can do an additional remediation to extensify the aftercare, so the monitoring which we perform on a yearly basis. And that's when we started to look at the possibility for bioremediation. It started with a general screening of what kind of specific bacteria do we have on site which degrade chlorinated hydrocarbons. They are well known and well defined in theory, so you can very specifically search in your samples for these bacteria. And luckily for this project, we found indeed large amounts of bacteria which are present on site and can have the ability to degrade chlorinated hydrocarbons. And one down part of this site was that there were no nutrients which the bacteria needs to incorporate during the processes to generate degraded products. So we did a feasibility study. I mean, how much do you need to stimulate the bacteria and how much will it cost? And it was a positive balance, and therefore we started to stimulate the bacteria by giving them simply nutrients, which was a carbon source, because that was lacking on site. And we started to monitor. As you can see on the chart, the first injection of the carbon source was already in 2010. So now 12, almost 11 years ago. And what you see in the chart is that the degradation product, which is cis and VC. Cis plus trans, that's in the green chart. So the green line, this green line, which is a degradation product of per entry. It started to increase once you added the bacteria. See, that's the addition point is displayed by the vertical dotted line. And at some point you see the degradation products going up and up and up, and then it starts to go down. Of course, because then all the substrate and nutrient is used up by the bacteria, so you have to add more of the substrate. That's why we go for some second edition points in 2017 and 2018. And what you can see in the data in terms of concentration for per entry is that over time it decreases, but it doesn't decrease linearly. It goes very, very gradually. But for our purpose, I think for the past, we can reach a level where we do not need to monitor this on a yearly basis, which means we can extensify it and we can help the client to cover this part actually. So that is one of our examples of how we perform this already well-established techniques in practice. But we do not only believe that applying already established technique is the only way to go. Before we like to be on the front part of one step ahead, you need to think about what are the current and what are the upcoming challenges which client will face in practice. And therefore, a little bit of innovation is a must, I must say. So we perform pilot studies on site, on the field itself, to see how we can incorporate different kind of processes in our work. And one of our concerns were that usually when we come up, it's already a little bit late, so we have to perform remediation. But what about preventing? I mean, that if you are able to prevent, I think it's more effective. So we started to look for a very early sensor, and we were like, is there any difference in microbial communities present on polluted and non-polluted sites? And we just went to one of our project sites, which was a former landfill, polluted with heavy metals in the top layer and the groundwater, and just took samples to get a first screening. What do you see? What do you measure? And what we could see is that with different types of pollutants and different degree of pollutants, you get another view of the composition of the microbes that live there. On the right chart, it might seem a lot, but it's just 5 samples, which is displayed in this chart, done in triplicates. For example, if you choose the first one, that's just number 9, it had a very severely polluted with copper and lead. And this categorization of light, moderate, and severely is done by the Dutch Soil Protection Act. Then you can see, for example, that this species is less present in the polluted sample compared to the one that is present in the control sample, where there is no no known pollution of these heavy metals. So that's just the first example. Of course, we need to figure out a lot of dynamics, what are happening and those kind of things. But this is an approach from top down. Let's see, you downscale the problem that you're seeing in your environment. And one of these, the goal of this project, this pilot study, was to make a new decision-making tool for our policymakers, So translating this into very simple, how do you say it, like a traffic light. For example, if you see these type of bacteria, it's a go or it's a no-go. So that there was a purpose behind it. But one thing which in conclusion is that we do not only apply already well-established techniques, but we also perform innovation to be beforehand, especially for bioremediation and dynamic sensing purposes, and also for designing practical tools for our decision makers. One of the upcoming events where you can participate, and of course this is a platform to get to know Sweco, share your knowledge, and and also a little bit of networking. It's already this Friday, which is a water case day. So we're going to discuss actual problem which is in the field of water, and it can be different kind of waters, groundwater, surface water, so in general. And you can also meet the water specialist and to talk about your mutual interests. And on the other hand, we're going to have a new office in the Rotterdam city, and this is not solely an opening, but it's a moment to stay in touch with all our clients, stakeholders, everyone who's interested. So if you would like to come, do not hesitate to call us. And at the end, from a Sweco point of view, we believe that bridging fundamental findings and practical challenges is the key to tackle all the problems efficiently. So for me, it's now left to thank you for your attention, and do visit the virtual booth of one of our offices. Thank you.
Thank you very much, Shaya and Ferike. Are there some questions for Shaya and Ferike on Sweco's activity, notably on bioremediation? Do we see something in the chat? Or you can unmute your microphone. So again, let's make the video challenge as much as videos that we can display on the display. So it would be nice also for us to see each other. So do you have any questions for Shaya and Ferike? I know that it's early morning in Europe. But so maybe a question for me to start with. So how far are we to link amplicon sequencing data to policy making?
That's an interesting one, David, actually. It's very much in the early stages. It's new. It's not something which is a regular parameter in our acts and our guidelines which we use. So it's pretty new. But on the other hand, I think there is room for improvement. Of course, these type of conventional way of measuring things and and comparing them against a certain concentration is pretty, I must say, outdated. We are now working with much more knowledge. I think there is room for improvement, so they are open, but it's not a must or something like that. But if you can show the benefit, how you can benefit from the data, and what you can learn, and how you can be one step ahead, I think that's the main focus. But one thing to consider also with amplicon sequencing, the data is pretty complex for non-experts to understand. So that is where we try to focus, simplifying the data, presenting in such a manner that stakeholders, policymakers can understand it. That's the main thing to focus in this area right now, I would say.
Yeah, because in the end, policy makers have to make a yes or a no. We should go for this solution or no. We should implement mitigation strategies or quality controls or etc. So indeed, it should support decision. Do you think that a dashboard like what Alaida presented yesterday can be something interesting that you could also implement in bioremediation context?
Yes, definitely. And the projects I showed is also not standardized. That's pretty new. And also in our brochure, which you can download from the site, we've explained the project for the municipality, where we also did some screening of microbes which are present on site, and then intensify the aftercare. So it is accepted, I would say, but you really need to stress on the benefits of it. It's not a standardized protocol yet. Still to come.
And the question will be, can we standardize these protocols? So we will see that across the day as well. There will be a session on methods, more oriented methods at the end of the day. We'll see. There are some questions in the chat. So Nina and Jay, do you want to ask them?
Yes, so there's a question from Professor Tom Curtis. Do you think better microbiology makes your company more competitive?
To be honest, I'm not really into the competitive part, but I think it's more our focus that we can help our client to be less concerned. So we can take the, we can benefit from the data, from the knowledge we have on the microbial part, and we can generate, and that's a practical focus, and help our client via that direction. It's not per se competitive, because we work a lot with also different types of organization. But I would think that for us, it will help to stay focused, to have our client focus.
Maybe a second one, and then we will move to the posters.
Yeah, so Dr. Eskiel Santillano also has a question. Maybe he can ask it himself. Do you want to unmute yourself?
You guys hear me?
We cannot hear you.
Cannot, huh? So then,
Yes.
Okay, yeah, now we can.
oh, you said you could. Oh, sorry.
Yeah, now we can. Now we can.
Okay,
Yes.
awesome. Thanks for the presentation. I was wondering, when you were talking about bioremediation of hydrocarbon, chlorinated soils, these oil spills, right, for example, are you guys using an engineered microbial consortia of a few strains that you know about, or is it more like a complex community approach? And if that information could be shared, because it could be proprietary. So that's my question.
Yes, thank you so much. Very, very clear question. These are already bacteria which are already known to degrade these compounds. So it's not an engineered one. They are locally present at the soil itself, and also the research, the scientific research, which is behind the application, has shown that they degrade these type of compounds. So it's a well-known bacteria.
All right, thanks. By engineering, I probably used the wrong word. I meant the consortia. You're picking certain strains that you know they're going to work well together. Let's say it could be 10, 15, 20 strains. But yeah, thanks.
Since we aim for interaction, so maybe we can let also Paying, I think, ask the question. I think there is another question. And then we go to the posters.
Yes, there's another question from Dr. Paying Hong. I don't know. Do you want to unmute yourself and ask your question?
It could be nice.
Okay, hi. Can you hear me now?
Yes.
Yes.
Okay, I'll just go on. So I want to thank the presenters for a very excellent presentation. And I'm very intrigued by the idea of using microbial communities as a dynamic sensor. Can you just kindly elaborate a little bit about how dynamic do you think, when you're referring to it as a dynamic sensor, how fast does it actually respond to perturbations, to stress events that you can make use of it as a sensor? And usually, how fine is the resolution? Do you need to identify it at the genus level or the species level? So with that in mind, it will kind of govern what kind of examination we need. For instance, would it be deep sequencing or not? So I'm not sure if if you can just elaborate a little bit more in terms of how you utilize microbial communities as a dynamic sensor.
Yes, thank you so much. The data I show here is solely done by next generation sequencing. So I think it's a pretty easy for the microbial community to go for that. And to what extent the resolution, that's something we still need to figure out, because this was already an existing site which has been polluted for like more or less 20 years. So I believe that the microbes living there has also been adapted. You see differences with the level of pollution, but when do you see the difference? For example, if there was a difference in concentration of 10, 20, 30, we do not know yet. So that's something to figure out. I'm pretty curious also. But I must say there is a large difference in being moderately polluted. For example, if something is moderately polluted, which is displayed as larger than T, so this part, then you can say that the larger than I, which is severely polluted, is twice the amount of this one. So it's a big difference. But to what extent, where is the fine line? I still need to figure out. So I cannot answer in numbers what the resolution is. But it's something nice to indeed figure it out in a practice, and how fast it changes, of course, in time. That's also to figure out. So therefore, you will have to do, of course, time lapse experiments, which has not yet been carried out.
thank you very much, Shaya and Ferike, for your presentation. And you will have the opportunity to talk to Shaya and Ferike at the e-booth, but also they will interact with us in the roundtable of the first session. And probably do you stay the whole day here?
Yes, we are, and tomorrow we're also online, so many moments to have a chat with us.
So please visit the e-booth and have a roundtable with them as well. Thank you so much, Shaya and Ferike, and a round of applause again. So it's time for you to go in the poster rooms and to interact with each other, to read about the posters. I don't know what it is. It's interesting. And we see each other again at, let me check, 9:30 Central European Time for the keynote lecture of Takashi Narihiro from Japan on microbiomes. Thank you so much, and we see each other in 45 minutes. Bye-bye.
Woo!